Hello, everyone. Okay, now you should hear me. So, thank you for attending this session. In this session, I would like to tell you about Red Hat SBOM journey. But first, let me introduce myself. So, my name is Przemyslaw Roguski, but I know my name is pretty difficult to pronounce. So everyone calls me Rogue. And I'm a big fan of Star Wars, so that's why Rogue. I'm a principal security engineer at Red Hat. I worked at Red Hat since 4 years already. I'm mostly responsible for production and improvements of Red Hat security data, including SBOM, CISA, VEX. I also work as a design architect, where I design various solutions, processes related to security internally for Red Hat and also externally for Red Hat customers. I'm also an active member of various community security groups. I'm co-chair in the Mitre CW using Spring working group. I'm also a member of Oasis Open EOX, that was mentioned a few minutes before in the previous session. I'm also a member of CISA VEX working group and also leading the Red Hat vulnerability certification scanning program. Okay, so that's it about me. Now let's move to the main topic, SBOMs. So my plan for this session is to go through the SBOM basics from definition, how to understand what are the types of SBOMs. Then we go through the relationship between SBOM and product lifecycle and also software development lifecycle SDLC. Then we will talk a little bit about Red Hat SBOM implementation. It will be a little bit more technical part of this presentation. And then at the end, we will talk about SBOM challenges. There you go. Okay, so let's start from the basics. SBOM, software bill of materials. Many of you may already know about this, but let's just focus on the highlighted, maybe the most important things. SBOM is a machine readable, which is very important, comprehensive inventory of software components and dependencies, which we also call software manifest, including license and provenance information for the very specific version of product. By default, SBOM files are considered to be static files associated, like I already mentioned, with the specific version of the product and release date. In the other words, SBOM file is a representation of the product for that particular point of time. SBOM files helps establish reviews and for procurement and audits. And also, it is important to know that SBOM files allows vendors and also customers to track components and their dependencies, including third-party and proprietary artifacts. SBOM files can help also in the vulnerability management process with support from security data, like CISA VEX files. SBOM, by default, does not contain security data. SBOM files also does not include attestation data. Attestation data, I mean here, all vendor statement of fulfillment of specific security requirements. There is a direct relationship between SBOM, CISA, VEX, attestation, all of those three types of data. But it is really important to know where to find which information. Tomorrow, my colleague, my teammate, will tell you more about CISA VEX. Today, we will just focus on the SBOM itself. So we know the SBOM definition, and we know how to understand what should be included in the SBOM. Now, SBOM files can contain very many different useful metadata. Depending on the use case, different type of SBOM can deliver the most valuable and useful information. That's why CISA defined 6 types of SBOMs. We have design type, source, build, analyzed, deployed, and runtime. Design covers all information related to the software doing the design life cycle, when you know you don't know exactly what will be used, but you know what you want to build and what to deliver. Source SBOM covers all sources information that are used to build specific product version. Build everything that is used to build a specific components. That includes build time dependencies, runtime dependencies. Analyzed, it's another type of SBOM where you can include more information specific to the build pipeline, for example. Deployed, it's another type of SBOM specifically associated with the product that is deployed in the customer environment, and the runtime focus on the runtime artifacts. Now, SBOM can be public or private, depending on the type and also depending on the vendor distribution, software producer distribution model. Well, in the industry, it is still not very well defined what the official SBOM should look like. Red Hat worked, and still we participate in many discussions with other software vendors, security working groups, upstream security working groups, also that includes scanning vendors, to define what exactly should be included in SBOM depending on the use case, what are the requirements, how to meet those requirements. Red Hat Product Security publish official Red Hat SBOM files for all the whole software products that are in Red Hat portfolio. Currently, the SBOMs files that we produce are still considered as a beta for customer testing. The GA version will cover those three SBOM types. Source, that will be publicly available for everyone. Those public version of SBOMs will not include a validated license data and provenance. There will be also built SBOM type. This type will be available for licensing customers. That will include build time manifest and verified license and provenance information. And also there will be available analyzed SBOM. This one will be available under more in-depth NDA, and that will include additional information about Red Hat, for example, Red Hat build pipeline infrastructure. Now, here I would like to highlight one thing, because we talk about different type of SBOMs, what information should be included where to find what type of information depending on the use case. Now, how about what is the best time to build SBOM? Here I decided to use a real example. This is one of our containers. This is part of OpenShift, Red Hat OpenShift platform. For this particular container, I generated an SBOM during the build process. It's on the left side, you see source SBOM. And then I also generated SBOM for the final release build. So it's a build outcome. As you can see, the number of RPM packages is almost the same, but there's a big difference between specific language packages like Golang or JavaScript. Why there's a big difference? Because if you generate SBOM too late, you are losing a lot of useful information about what was used to build your software, what was used to what was used to compile something, how it was included, how it was built. That's why generating SBOM in the right time will allow you to generate the right information that you can then later deliver to the end user, to the customer. Now, we talk about SBOM as we already discussed about SBOM definition, how it should be built, what to expect. Now, how to associate SBOM with product lifecycle. At Red Hat, we have a really big portfolio. It is very important to understand that every single product has individual independent lifecycle and support model. Even if we talk about products that rely on another product, like OpenShift Container Platform, use RPM packages from Red Hat Enterprise Linux. Both those products has their own independent lifecycle. In product lifecycle, we can distinguish 3 levels of product versioning: Xstream, Ystream, and Zstream. Xstream, it's like major GA, main version of the product, like RHEL 8, RHEL 9, OpenShift 4. Ystream represents the specific product streams in the main version. So for example, RHEL 8.8, 8.6, or OpenShift 4.12, 4.13, 14, different streams. It is important to understand that in one product version, there could be multiple streams supported at the same time, depending on your needs. And also we have these streams, which represents the regular updates, asynchronous updates released across one stream. Now, if we know now what to expect from SBOM, we know what is the product lifecycle model. I would like to show you on the diagram how Red Hat SBOM release process and release schedule will look like. From the left, we see 2 different products, RHEL 9.2 GA and OpenShift 4.11 GA. During the release step, we'll produce SBOM and associated CSAF VEX advisory. Now, later on, we have update to the RHEL 9.2. As you can see, at that time, there is no SBOM produced when we have an update. Why there is no SBOM? Across one product stream, in this case, RHEL, the number of packages is still the same. There is an update to one of those packages due to, for example, some bug fixes, new enhancements, or, for example, a vulnerability. So there's an update to existing package that was already included in the SBOM file generated during the GA. If you take a look at the next line, there is OpenShift 4.12 GA, and then we have a various updates to OpenShift. As you can see here, for OpenShift, even for the Zstream updates, we will also release individual SBOMs. Why? Only because in OpenShift, there is a different lifecycle model, different build process, and every single Zstream update may contain completely different list of packages and dependencies. That's why for this product, we will produce SBOMs for every single Zstream update, because it is important to know what exactly is included in this released version of product, which is not the case for RHEL. That's why on the Red Hat side, we will produce SBOMs, different SBOMs in a different time. There will be different SBOM schedule depending on the product version and product lifecycle model. Now, if we know how SBOMs will be produced by Red Hat and when SBOMs will be released, how to associate SBOMs with software development lifecycle, SDLC, SDL. Red Hat is seeing increased SDL-related requests from all our customers. There are more and more questions about various activities that we do as a part of SDL process. And I decided to include a couple of slides how SBOM can help in SDL. What is the role of SBOM in the SDL activities? here is list of different Red Hat here we see a list of different product lifecycle phases, and during all of those phases there are different SDL activities on the Red Hat side. Here is a diagram that can visualize a little bit better. Now it's a little bit different sound. So here you see one product stream, Y stream, life cycle, starting from the planning phase, ending at the maintenance and end of life of that stream. During the develop phase, as you can see, this arrow is just at the beginning because at Red Hat, our design and develop phases are pretty close together. During the develop, we produce the source SBOM. Between develop and maintenance, we have regular continuous updates. Here we have those Z-string updates from the lifecycle diagram. During the build phase, we produce the build SBOM. Release is, like we already discussed, the time when we publish our SBOMs. As a part of the maintenance, we can deliver the analyzed SBOMs depending on the customer requests. Let's take a little bit closer. So all of those three lifecycle phases and how SBOMs can help them, and how SBOMs can be used in those phases. So in the develop phase, we produce source SBOM at that phase. Now, during this develop phase, we run many different SDL activities. Outcome of those activities, like SCA or SAS security scans, could be directly associated with produce SBOM. So we know what exactly we build, what we develop, what is the scan result of this SDL phase, and how to associate it together. The same for build lifecycle phase. We have build SBOM, so we know what exactly was included to build specific component in this specific product, and then we can associate the outcome from the SDL activities in this phase with this particular SBOM. For example, malware binary scanning results. Release phase, in this step, we produce SBOM, like we already discussed, and in this step, we associate specific product version with the exact SBOM file. In maintenance phase, like I already discussed, we can provide analyze SBOM and include additional information depending on the customer request, like information from about the Red Hat build pipeline environment, or for example, some SDL tests, SAS, DAS, or pen test results. Currently, SBOM files that are produced and published by Red Hat are delivered in the SPDX format. Right now, we have a discussion how we could support also Cyclone DX. In the Red Hat SBOM file, we can distinguish three key sections: document metadata, product and components metadata, and relationship between components, their dependencies, and product itself. So now let's take a little bit closer to all of those three different sections. I hope that you can read it. So in the document metadata, you will find information when the SBOM was issued, what is the vendor who produced this SBOM, in this case, Red Hat Product Security, and there will be also a consolidated list of all licenses. Product metadata. Product metadata delivers you all information about the specific product release. As you can see, you can find a product name. I highlighted it on the bottom. Exactly the same name you will be able to find in our security data. That will allow you to associate SBOM with the security data like CSLVEX files. And also in the product metadata, you will find information about the product CPE ID, unique product identifier. Product metadata is the last item in our SBOM file. Product metadata is the last item in the product and component sections. In a moment, I will also show you another way how to find the product metadata in much more faster and efficient way. First, let's take a look at the component metadata. Component metadata contains all information about the specific component, dependencies, sources, including also license. Component details are expressed in the full format. Here on this example, you see RPM package. In this case, it's Cryo tools. So it's taken from the OpenShift SBOM. Another example is a container component. Again, details about this component in the pool format. You can see it in the pool type, namespace, and also component name and its version. Let me show it to you in this way. Here we have, again, another example of the component metadata. In this example, it's a non-RPM dependency. I see that my presentation created in Google is not displayed here correctly, but okay, we can make it. This is a non-RPM dependency, like I said. This one is a Maven package. Another one, both should be presented at the same time. Another one is a Golang package, part of the Golang standard library, net HTTP. Now, at the end, there is relationship section that connects all components from the SBOM, packages, containers, their dependencies together, including also relationship between those components and product itself. In Red Hat SBOM file, we use SPDX relationship types, contain byte, describe, dev dependency of, generates, package of, and variant of. On the right side, I decided to show you two examples how Cryo tools component RPM package is represented as a part of OpenShift 4.13 product. On the bottom, there is a Golang dependency at HTTP package as a part of the OpenShift Thanos container. Now, we very quickly go through the SBOM definition, SBOM production, SBOM Red Hat implementation. Now, let's talk a little bit about customers' expectations versus SBOM challenges. Okay, I'm also a car maniac. That's why there is a car engine in the background. So when you buy a car, you expect that all parts supplied to be genuine, and also that there is an accurate list of all parts in your car that you can always reference, you know what is there, and when it was produced, and so on. Can you say the same thing about every single part, every single component in your software? There is many challenges. In this diagram, I would like to show you a typical use case where Red Hat as a vendor produce SBOM. Let's imagine in this case that is an SBOM produced for our universal base image, UBI. Then we have another vendor, software vendor, who uses UBI image as a first layer, and then they put something on top of this UBI image, and this is their application built on top of Red Hat UBI image, and then final application is delivered to the end user. Okay, if you know this use case. Now, what should be included in the final SBOM? Should we include only the application part from the vendor who owns the application? Or maybe we should include consolidated SBOM. SBOM from Red Hat UBI image plus SBOM for that application that is on top of it. Now the question is, should we include everything? And to demonstrate a little bit different example, let's take a look at Red Hat Quarkus product. Quarkus is a product that you use to build your Maven applications. Of course, like I already mentioned, Red Hat Product Security produces SBOM for Quarkus as well. Quarkus is an environment. You deploy it on your site. We deliver you very detailed SBOM that includes Quarkus dev dependencies and runtime dependencies. Now we have situation where customer, the software vendor in the middle, uses Red Hat Quarkus environment to build something. They build application, they deliver that application to the end user, to the final customer. Now, let's imagine that there is a vulnerability reported against one of the Quarkus build-time dependencies. Real example, Quarkus Kubernetes deployment. This is one of the packages. In this example, if there's a vulnerability reported against this particular component, who is affected? Final end user? Not at all. The vendor who built the application, because they have that Quarkus environment, they use that product, their environment is affected. In this case, if to produce the final SBOM, the software vendor who built the application will take the whole Red Hat Quarkus SBOM and they hand over it to the final end user, and that end user will use that SBOM to do something related to vulnerability management, like run a random scanner. We will end up with the situation that the final user will get an alert that they are affected by Quarkus Kubernetes deployment vulnerability, which is completely not the case here. So again, what should be included in the final SBOM? How to handle this? Again, another question, who should be responsible for the final SBOM production? I intentionally put this question here to this slide because last week I discussed exactly this use case with one of our security scanning partners. And they told me that there's an expectation from the final end user that scanning vendor will be responsible for scanning the final application, final product, and based on that, they will do vulnerability assessment, vulnerability management process. But like I already showed in the previous slides, if you scan product too late, based on the final already created builds, you're losing very important information from the build process. So you cannot do efficiently vulnerability management if you are trying to scan something too late. So this is another very useful question. From Red Hat side, we want to deliver solutions to address this type of problems. Maybe not all of them, but at least limited the impact from them. So that's why we encourage everyone to use trusted content. All developers could then focus on the most important work for them to develop something funky, something useful. They don't need to worry about security of those components. To help to use developers trusted content, we all have in offer right now a service which is called a Trusted Profile Analyzer. I encourage you trying it. Right now it's in a tech preview version. It allows developers to build applications, to generate SBOMs, to upload SBOM and see some vulnerability statistics based on those uploaded SBOMs. It also allows you to download Red Hat official SBOMs for the particular products or components directly from that platform. So we talk about SBOM production. For now, we were only focused mostly on SBOM components, artifacts. We didn't talk about licensing, software license issues, how SBOMs can help to address all of those problems related to licensing, how to handle license problems. Should we classify them as weaknesses, vulnerabilities, or maybe only some security supply chain issues? This is a serious problem. Right now, as a part of the CW program, we have a discussion how to cover software licensing issues in the CW program. SBOMs produced by software vendors, verified by vendors to make sure that the right license is included in that SBOM, can address many of those example problems like various open source violations or software that is written with a dependency that was licensed for educators or students. So you shouldn't use it in your final production environment. Or, for example, developers who just made some mistakes. So SBOMs generated accurately can address also this type of problems, regardless how we classify them. Because seriously, software licensing issues are real. At the end, I would like to talk about another problem related to SBOM consumptions. Because we talk about SBOM production, SBOM delivery problems, how about SBOM consumption? How customers can be able to consume all of those different SBOMs efficiently? You can imagine a situation that there are customers who have in their environment many versions of one of the same product, and there are products from different vendors. They produce also some other software for their own internal usage. So now there must be a way to consume all of those SBOMs and analyze them efficiently. Another problem is what we already discussed, how to ensure that the right data are included in the final SBOM produced by vendor. Here is a big challenge, in our opinion, for CNAs, software vendors who are responsible for CV assignment to their products in case of discovered vulnerabilities, to make sure that the SBOM data that they produce and security data, regardless of the format, CISA VEX files, for example, are compatible with each other, that end user, final customer can easily connect SBOM data with the security data. So, as a summary, we went through SBOM definition, different SBOM types, what to expect from different type of SBOMs, how to use SBOM efficiently depending on your use case, how to connect SBOM and product lifecycle, how to use SBOMs as a part of SDLC. I showed you very quickly what is the Red Hat SBOM implementation approach, how we will release SBOM files, what will be covered, and we quickly talk about SBOM challenges like consumption and delivery problems. Thank you very much.
For all the excellent information. Do we have any questions either in the room or online? Couple, here you go.
I just wanted to confirm, you were talking about the trusted profile analyzer, and you mentioned that that is where others are going to be able to access the SBOMs that Red Hat is making available publicly. Is that right?
Yes, that's correct. Yeah.
And then did I see in there that you're also able to import SBOMs or do other things with SBOMs you already have?
That's correct.
Awesome. Going to give it a try. Thank you.
Yeah, try it. Right now it's tech preview, so you can try it.
Hey there, I have a couple questions. What was sort of the buy-in for Red Hat to adopt SBOM into its infrastructure and processes, and then how do you motivate or incentivize other companies to do so, like Red Hat? So SBOM isn't taught in software engineering, where you learn how to develop the software development lifecycle. So what would you recommend, and also why did you do it?
Very good question. Thank you. So, okay, I will try to answer it in this way. Exactly like I decided to title this presentation. Everything is related to the transparency. We want to make sure, and we want to encourage everyone, that it doesn't matter how exactly, it's not that not exactly, it doesn't matter. It's not that important what format you want to choose. You must be, the most important thing is to make sure that you can deliver accurate information, what exactly is used in your software, how it was compiled, how it was built, and what data, security data, you can deliver for all of those components and products. Because that's what we see, it's a big problem for end user perspective to understand what exactly they have in their environment, how to call it. For example, many times when we ask them, oh, okay, tell me what component you think is vulnerable, and it will help us to address some of your concerns, and they don't know how to understood what component is. So transparency, very logic information connection between product, support model, components that are used in this products, and also all of those components dependencies. This is something that is very important in every single product, for every single product software vendor. And this is what we use as information to encourage other software vendors. That's, hey, everyone should be aware how to understand your product and how to connect it to the publicly available information about various vulnerabilities. Is it a good answer? Thanks.
Great. We have a question from an online participant, Eric Grigor. Eric's question, you talked about using Cyclone DX. Are you going to maintain both SPDX and Cyclone DX? If you're going to switch to Cyclone DX from SPDX, then why?
Like I mentioned, right now we have internal discussion when we want to support Cyclone DX, and like it was already mentioned in not mistaken in the previous presentation, and what I already mentioned as an answer to the last question. It's not that important what format. It's important what data you can include to your file. So yes, we have an intention to deliver our SBOMs in Cyclone DX as well. At the time, we will just support both versions, both formats.
Give me a second to catch up here.
Hi. So first of all, I guess kudos to Red Hat for leading the way with the publishing the SBOMs. I think Red Hat is the first, like the big organization that is publishing the SBOMs.
I think so.
So my question is about the ownership. So I believe that in most organizations, it's the product security, application security that is the ownership of the SBOM process. who actually should be the owner of that process? I don't think that security is necessarily responsible for that part.
Very good question. It really depends on the company structure. SBOMs, like I already presented, the best approach is to produce SBOMs during the build process as a part of the component software build process. But it is really crucial and it is very important to make sure that you include the right information. You didn't include not necessary information, because depending of what is your use case, different type of SBOMs are generated. Is it a product security domain? Yes and no. Yes, product security can ensure that we can easily associate produced SBOMs with security data. That is especially domain for product security. So without connection between SBOM and security data, then, you know, SBOM usability is a much smaller. I go first.
Okay.
Go ahead.
I had a question. So you said you produce SBOMs for specific Red Hat versions. You showed, for example, RHEL 9.2.
Yep.
And then I assume you generate also SBOMs for each of the RPM packages.
Can you repeat that?
You generate SBOMs for each of the RPM packages.
SBOM by default is for the product. So not for every single RPM package itself. It's for the product as Red Hat Enterprise Linux 9.2.
And what happens when there's so if you generate a new version of one of those packages, then you only release a CSF, VEX advisory?
Yes, that's correct.
So all of you lose the information about the newly built packages?
Like I mentioned, across one product stream, then the number of packages are still the same. So if we want to introduce a new package, new functionality, new feature, then it will be included as a part of the new RHEL 9.4 release, for example, or 9.6, and so on and so on.
But individual packages still change across those releases, right?
The versions of the
versions
across the one product stream release. Yes. So the packages versions will be different, and that will be reflected in the CSAF VEX files as a advisory.
Okay. So not in a standard SBOM.
No. You know, there is right now discussion because, for example, we produce SBOM for UBI images, which UBI image itself is not a product, it's a base image. So right now there is discussion, open discussion, if this is something that maybe we would change and deliver SBOMs for every single package as well. But then you have to remember that every single package is directly associated with the product. So we have situation that, for example, single package like OpenSSL is produced and available in Red Hat Enterprise Linux, and at the same time is available and delivered as a part of, for example, OpenShift data path, or for example, OpenStack, or even OpenShift. And then if you have an SBOM for OpenSSL, you have to be able to connect this particular package with a specific product, because then in case of OpenSSL vulnerability, there can be different status depending on the product. So there is an OpenSSL vulnerability. Red Hat Enterprise Linux will be affected by this vulnerability, but OpenShift may not be affected by this vulnerability at the same time. So you have to know which OpenSSL version you have in your environment.
Yeah, but okay. Well, I'll look you and continue this later.
So the title of your talk was the future of transparency information. I wonder what you think the future of SBOMs is. Is it having more fields in an SBOM? Is it having SBOMs at every stage of your development process? Is it more accurate data? What do you think like SBOM 2.0 is going to look like in 5 years?
To be very honest, it's really difficult to predict what will happen next year. It really depends on the requirements and how everything will be developed. So I can imagine that there will be much more information included next year than it is today. Maybe we'll produce SBOMs for every single step in the build pipeline, and store information. What is the outcome? Yeah.
Okay, any other questions? I don't see any additional ones online. Oh, yeah. See you guys.
You mentioned the lab or app where we can look up the SBOMs and integrate. How can we find this on Red Hat portal? You had a screenshot of the trusted analyzer,
Yeah.
profile. Where people can find it?
Right now, Trusted Profile Analyzer is available directly from the console.redhat.com. So you can go to the console.redhat.com and you can find Trusted Profile Analyzer link there. And I also put a link here. So I'm not sure if presentation will be distributed somehow to all participants. Okay. All Red Hat SBOMs are also available directly in our public repository. So you can also download SBOMs directly from there.
Yeah, the video will be available on YouTube, and the slides themselves should be on the first.org website, maybe a week after the event.
So can you say anything more about the SBOM journey? So there is obviously a lot of technical work that had to be done to reach this maturity. But given the detailed information that is provided, information about the vulnerability, information about the licenses, did your organization encounter any, I don't know, breaks or stops, like legal saying, oh, we cannot publish this SBOM, or we cannot publish this information because X, Y, and Z? So any guidance to organizations that want to start publishing SBOMs, what are the pitfalls that one should be careful about?
Well, yeah, this is a very good question, because Red Hat SBOM journey was difficult, long. It required a lot of work. Yes, there's a lot of challenges, starting from the way how SBOM should be produced based on manifest, then how to deliver everything to the end user efficiently. What exactly should be included? So we had a lot of discussions with our legal teams as well. What can we include? What cannot be included? That's why there will be 3 different types of SBOMs. There will be, like I said, publicly available version, also licensed customers version, and SBOMs that will include very confidential information, and that will be available only for the selected customers under a specific NDA. So recommendations. Oh, this is very difficult question, because there are so many challenges in every single step almost. So it's not easy, but it's really worth, and this is something that every single software vendor should do. I think that there is no other option.
Hi. I'm curious, and maybe this is for tomorrow's with the VEX and whatnot, but the use of SBOM for vulnerability response. How are things like backports documented and managed? Like, so if I'm wanting to provide vulnerability response and use the SBOM as would I be would the SBOM be updated? Would the VEX stuff be updated? Like, how does that work?
That's a perfect question. Thank you. So let's take a look at, let's just pick up the real example, and it will be better to answer this question. Let's imagine that today there is a new announcement about vulnerability against OpenSSL package, right? Or kernel or whatever. Then you will have a Red Hat SBOM as a representation of your product, specific product version. So that will give you information that you can quickly find out if you are potentially affected by this vulnerability, because you know if OpenSSL is used in your product. It doesn't matter what is the product. It doesn't matter if it's OpenShift, Rail, whatever. You know that, yes, I see OpenSSL on my list. Based on SBOM, you will know how to interpret this information. Is it a dev dependency? It is a maybe only dependency used as a part of a component. What is the component name? Maybe this is something that I don't use at all. So that will at least give you information where you are, if you're potentially affected or not. Now, if you know that, okay, I'm potentially affected, what to do next? Now I can go, knowing the product ID, I can go to Red Hat vulnerability data, CSAF VEX files. You can find this specific product and information about the component. Maybe it's OpenSSL itself as an RPM package. And there you will find information, okay, what is the Red Hat statement to this specific vulnerability? Is my version affected or not? If it's affected, then you will see, okay, I know that I'm affected. I'm waiting for update. Next day, there might be an update to the specific VEX available in the specific VEX file for this particular CVE ID that, okay, now it's fixed and fixed available in this specific OpenSSL version. Maybe it will be backported, but from your perspective, it doesn't matter. You know exactly what is the version. You can compare it with your version. This is something that also scanning vendors will use as a reference to tell you if you are affected or not. If you are affected, what is the update available to you, and so on.
Okay, so it would be in the VEX. From the timeline that you had laid out, I wasn't sure if the VEX was updated at, you know, certain milestones or if it was a continuously evolving document.
It was. There you go. So here is only a presentation of when the specific versions of the product are released and where we again also release SBOM. And at the same time, we will release CSAF advisory, right? But separate to this SBOM schedule, there is a VEX schedule, VEX timeline. So like I said, SBOM file is a static. We release it when the product is released. And this is a presentation of the specific product version at this point of time. Now we have VEX files that are updated all the time. It's active file. So every single time when you take a look at it, the status might be different. At the beginning, it could be under investigation. Then 5 seconds later, it could be, okay, it's already checked. Now it's affected. Next day, it could be, okay, already fixed. This is an update. That's why vulnerability information, vulnerability data are by default are not included in SBOM itself.
Right. Okay, thanks.
Okay, thank you very much. I think that it's the end.
Thank you, Rogue. Appreciate your time and your expertise.